And welcome back. We are going to continue our review. This time we're going to touch base on the topic of sorting. For example, we have an array and we want to sort that array from, let's say, least to greatest or greatest to least. And there are, of course, two approaches that we've talked about that we are going to head and look at once more. The first of those is the bubble sort. Now, with the bubble sort, the thing you have to remember about it is that it uses nested for loops. And that's how we kind of traverse through the elements in the array. Now, how the bubble sort works is that it's a sorting algorithm that pretty much checks two elements, looks to see which one's either greater or smaller, depending on how we're using the algorithm, and then just swaps them to their correct positions. This is one of the easiest sorting algorithms to implement because it's just two nested for loops. However, it does have a big O of n squared for a worst case runtime, which makes it a pretty inefficient algorithm. It's also considered to be pretty slow because you have to literally go through each and every single pair, and then as soon as you're through that first row, you have to go back and check it again for the next row, etc. All right, but this algorithm is actually very stable because, again, it's just two for loops, so you don't have a chance of some weird behavior or anything happening like that. Now, the bubble sort is not the only algorithm that we examined. We also took a look at the selection sort. Now, the selection sort uses a combination of methods and for loops to sort through the array. In this one, looks to select the minimum element from the array and then put that elements back into its correct position. Now, it does have some slight improvements over the bubble sort algorithm, especially when we start looking at larger sets, because we have a large set of data. The bubble sort is actually going to become very inefficient, and that's why this is considered a little bit more efficient than bubble sort. If you look, it has the same worst case runtime, big O n squared. It's a little bit faster because it doesn't necessarily need to go back through the entire array, but it doesn't necessarily have the same stability as that of the bubble sort because there is some more complex things that have to happen behind the scenes for this algorithm to properly function. So let's take a quick look at these two algorithms and compare them side by side. One of the things that we talked about is that a bubble sort, of course, is less efficient than that of a selection sort. And this is really easy for us to see, even without having to get into runtimes or anything like that. We can just use a simple count variable to kind of track how many hops or how many times we're going through a loop iteration. And we can track this with the bubble sort, and we can sort a random array into however it wants to go. Or if we want to do a selection sort, we can do the same thing. And of course, the bubble sort should have, for most part, especially as you get into larger and larger sets, more hops than that of the selection sort. Now, we will eventually discuss other algorithms and techniques as we advance in this course and beyond because, again, the bubble sort and selection sort are only two sorting options or two algorithms that we can use when dealing with sets of data. All right, and now I'm going to pop on over to Eclipse, and I have here a bubble sort class, which, of course, you could implement this here inside of your main class if you really want to. And we also have a selection sort class here. And what I want to do is I want to go ahead and demo these just to show these how they work side by side. Now, I'm going to go ahead and use it with a set of 12 here to start. So we have an integer array size 12, and we're going to first fill that array. And then I'm going to make a copy because I want to compare the bubble sort and selection sort without necessarily having to go and ask the person to re-enter the array. So let's go ahead and do that. And we're going to first sort it by bubble. Then we're going to print it. And then we're going to see how many times does it take for it to go through those iterations. How many loops does it need to do? And we'll do the same thing with the selection sort. We'll sort it. We'll do an unsorted, and then we will do a counter. So let's go ahead and run this program. And let's go ahead and enter 7 numbers. And so we're just going to enter 7 random numbers here. Or 12, excuse me. All right, now with 12 numbers in, you can see that it has sorted them. And we have a nice beautiful selection here in bubble sorts. And with the bubble sort, you see it took 30 hops. With the selection sort, it took 11. Now, I did make a small error here. I had 7 here. That's why I got a little confused here because I forgot to change this here when I was testing out this program. But let's just see how this changes when I go down to 7 hops. Okay, so let's just do 7 iterations here, or 7 pieces of that array. And all we'll do is let's go ahead and enter in some random numbers. And you can see that the numbers are a lot closer here. So if we want to check this out even small, let's just go down to 5 iterations. So 5 here for our array length. I'm not going to worry about changing that text right now. All right, and you'll see that the bubble sort in this case is actually faster. So when we have a very, very small set like this, the bubble sort can actually be faster. But as soon as we make this into a much larger set here, and this time I will change this so it accurately reflects. If I go ahead and run this and just start typing in some random numbers, all right, you can see that the bubble sort is getting very, very inefficient in comparison to the selection sort. The bubble sort took 52 hops, or 52 count iterations for those loops, whereas the selection sort took 14. So this is a great way to see the efficiency of algorithm without even having to get into actually running a time test on it or anything. We can literally just see from the number of iterations we had to do that this program right here with a bubble sort is going to take longer. Now, there are still times a bubble sort could come in handy if you're not worried about worst case runtime, or you maybe have a very small data set to work with. Bubble sort is perfectly fine. But if we are going to start worrying about runtime, obviously you can see that the selection sort is going to come in much, much better for a choice.